Okay, so inequality word problems. Here's just some steps to writing our inequalities. So assign a variable to represent the unknown. I know a lot of you do not like to use a variable other than X or Y. But a lot of times when we're creating equations or inequalities and word problems, it's good to assign a variable that represents the unknown. So, for example, if we're talking about apples, choose A. If we're talking about um, fruit, choose F, whatever it is. Okay. But you don't have to do that. All right. And then recognize the proper inequality symbol. And sometimes this is the most challenging part of it. So we're going to go over some of those down here, some that you might see more often. Write an inequality that represents the problem, and it's very similar to the equations, except we have an inequality symbol. And then on some problems, we're going to solve the inequality to answer the original problem. And my suggestion would be to go back and make sure that your answer is reasonable with the question that is being asked. Okay, if you're being asked how much money did you spend, but you end up with a negative number, then you probably did something wrong. Or if you're buying candy bars and you ended up spending $5,000, okay, we probably did something wrong, right? So we want to check the reasonableness of this. So let's go ahead and look at our symbols. We've been graphing and solving, so we're pretty familiar with these, but we have greater than. And remember, I said that you need to read it from the variable side. So I'm going to put the variable where it needs to go. So this would be x is greater, and this would be x is less than. Is greater than or equal to, x is less than or equal to, and then x not equal to. So these in the second column, these are the phrases that when they're used, sometimes we don't know what symbol to use. Is no more than, meaning that whatever you're doing has to be less than. Okay. And when we go through the word problems, I'll explain this a little bit more. Is fewer than also means as less than. Is at least. So meaning that it is at least this amount, but it can be more. All right. Is at most, meaning it can't be more than. So it's less than or equal to. And then, of course, it does not equal. So let's look at these sentences here. 5 more than a number is more than 9. And I put this in here on purpose because it's using more twice. All right. So I bolded on some of them, I bolded the terms that you need to focus on for the inequality symbol. And remember, sometimes we write above the line and then we write our final answer here. So 5 more than a number is 5 plus a number. And then is no more than. So this section cannot be more than 9. No, is more than 9. Did I say no more than? I meant more than. Is more than 9 means that it is greater than. Now, it doesn't say is more than or equal to, or is at least. So I do not have an inequality symbol there. So we would write this as 5 plus n is greater than 9. All right. 1/3 of a number. What does of mean? What operation? Yes. So 1/3 times a certain number is less than or equal to 30. Okay. So this has to be less than or equal to. That one was a pretty simple one. Now we don't put the raised dot in between our coefficient and our variable. We put them together. So the correct way to write this would be 1/3 n is less than or equal to 30. Okay. Okay, this one's a little bit interesting. The minimum for the sum of a number and 6 is 11. Okay, the minimum means that it's the smallest number it can be, but it can be more than that. All right, so, and I would probably put minimum right here is the minimum. So the sum of a number and 6. So the sum of a number and 6, oops, that sum goes right here. Okay, so I'm going to write that. The sum of a number and 6 is a minimum of 11, or it's the minimum. So that means, anyone have a suggestion? Yeah. Huh? Yes. It's the smallest. This is the least it can be, but it can be more. All right. That's basically what minimum is saying. All right. The product of 4 and a number. Product means multiplying 4 and a number. And that product goes in between because we're talking about 4 and the number being products of each other. Is no more than 60. Meaning it can't be more than 60, which means it has to be. It can't be no more than 60. Think about that. Less than. It's going to be less than. Just not equal to. Oh, yeah. Less than or equal to. I'm sorry. So we have 4n. Wait, is no more than. Oh, yeah. It can be also 60. I had to think about that for a minute. I even have that answer down on my key. All right, last one. 2 less than 10 times the number is at least 4. Okay. So 2 less than is talking about subtraction. 10 times a number and 4. Okay, we're going to have to rearrange some of these symbols. So 2 less than 10 times the number. Do we do 2 minus 10n? Or do we do 10n minus 2? We're going back to equations when we have this tricky one here. Yeah, we have to move this over at the end of the 10n. Okay, so I'm going to write that. So we have 10n minus 2. And then we have 4 over here with some kind of a symbol. So is at least. That means this has to be at least 4. But it can also be more than 4. So it would be greater than or equal to. So other than one of these up here, maybe these first two, some of them can be a little bit tricky. You're going to have to move things around sometimes and then determine the symbol. So that's kind of what we're working with now. So let's go ahead and move to page 2. We are going to practice more writing, but then we're going to solve for the number. Okay, so since we just went over a couple, I am going to have you do the first 2 with your partner or someone, and then we're going to come back and check those. Okay, so let's do those 2, and then we'll check them. So I'm going to pause the video. Okay, so I've annotated my problems, and now I am going to set them up. So notice I've moved my sum in between 2n and 4 because it's the sum of these 2 numbers. Okay, so it's 2n plus 4 and then greater than. There's no at least or at most or minimum, so it makes it a little bit easier. Greater than 14. Okay. And in this situation, it's asking you to solve for the number. So we're going to go ahead and solve this. So I'm going to undo my addition of 4, and I'm going to subtract 4 on both sides. And I end up with 2n is greater than 10. And then I divide both sides by 2. And I get n is greater than 5. Okay. And now I am going to explain this a little bit. What that is saying is that the number, when you plug it in here, it can be any number 5 or more. Or no, I'm sorry, not 5 or more than 5. It can't be 5. Because then if I plug 5 in here, it would be equal to 14. And this says that it can't be equal to, it has to be more than. Okay. So a lot of times if you want to go and you're not sure if your answer is correct, you can plug this back into the equation to see if it's correct. So I'm going to choose a number, and you don't have to do this. I just want to show you, but if you want to, you can. I'm going to choose a number that's bigger than 5, and I'm going to plug it back into the equation to see if it's true. So I'm going to take 2n plus 4. It's greater than 14. So I'm going to do a check on this. And I'm going to plug 6 into here because that is greater than 5. And I'm going to see if my inequality is true. And I know by just looking at this, you can all tell that it's true. So I have 12 plus 4 is greater than 14. 16 is greater than 14. So this checks out. A number that is greater than 14, greater than 5 will make this inequality true. Okay. So this is just an example of how to check it. All right, let's go down to example 2. I have a number that is decreased by 3. That means anytime you see decreased by, you're going to move it behind the next number. So this is 3 is decreased. Oh no, I have that wrong. Sorry. The number is being decreased by 3. Oof. So a number is being decreased by 3 is less than or equal to 17. Yes.
Why is it that?
Because this number is being decreased by 3. If it were to say 3 is being decreased by a number, you would switch it. So have you guys, this is just what happened to me, is sometimes what happens to you guys, you have a question about a problem and you come up and you ask me your question and you're verbalizing what's going on. And then you're like, oh, I get it. Never mind. I've had that happen a lot. So a lot of times when you verbalize what you've done, you kind of figure it out. It's kind of what happened just to me just now. So anyway, all right. So what is the number? Here we're going to undo the subtraction by adding 3 to both sides. And we get n is less than or equal to 20. Now, if I wanted to check this, I could plug 20 into it because it says equal, it can be equal to 20. So it can be any number 20 or less. Whereas this one in the example 1 has to be more than 5 because there's no equal sign under it. All right, are there any questions about those two? All right. Look at numbers 3 and 4. So 3 says the difference of 3 times the number and 6 is at most 21. You guys think you could come up with the inequality on your own? I see some shaking of the heads. Okay. So let's do this one. If you're getting the concept and you want to move on, you may do so. If you get stuck on the back, because that one's a little bit more challenging, then you can work on your homework until we're done with this part. Okay. So here, difference means subtraction. Decrease by, difference, less than, those all mean subtraction. Of 3 times a number. So 3 times a number and 6. So this difference will go over here where the and is because it's the difference between the 3 times the number and the 6. You have to subtract those. is at most 21. Okay, at most. So this right here cannot be more than the 21. So it has to be less than or equal to. So it can be 21 because it says at most 21, but it can't be more than 21. All right. So let's go ahead and write this out. We have 3n minus 6 is at most 21. And what is the number? Okay. I think what I want to do is I want to go ahead and figure out the inequalities for 4 and 5 as well. And then I'm going to have you solve them on your own because that's something that we already know how to do. So let's look at 4. The product of 6 and a number. That means that we're going to take 6 and that number and multiply them because remember, product is multiplication. So we have 6 and a number. A lot of times that and is going to be replaced with the operation. So we're going to replace the word and with the multiplication symbol. Is no less than 78. Okay, if this is no less than, it cannot be less than 78, which means it has to be greater than or equal to 78. It's just saying it can't be less than. It's not saying that it can't be equal to. Okay. So we have 6n is greater than or equal to 78. Okay. Now here's what we're going to do. Okay. We'll come up with the equation for 5. When I'm done, I want you to solve those 3, but then I want you to try 6 on your own, coming up with the inequality for 6 on your own. Okay. So here it says that 21 is the maximum, so maximum here, for 5 less than twice a number. So we have 5 less than twice a number. All right, it's kind of flipped this time, okay? 21 is the maximum that it can be. So it can't be more than 21. So 21 has to be I have that 21 is greater than. Yes, 21 is greater than. So this over here cannot be more than the 21. So it's going to be greater than or equal to. Now, notice that 5 less than twice the number means that this number is going to be 5 less than. So this right here is going to go after. Okay, so we're going to write this out and then, hold on just a second. Okay, so I want you to go ahead and solve those, and then I want you to try coming up with the inequality for 6 on your own. So I'm going to pause the video. Okay, so here are the answers to examples 3, 4, and 5. And so what I did was on 5, because it was confusing, I went back in to check on it. Now I knew my answer was right from the equation I got, but how do you check to make sure the equation is correct? Well, it's saying I chose a number less than 13. I chose 12 and I plugged it in and I got 21 is greater than or equal to 19, and that's correct. And this is saying 21 is the maximum. It's the most that it can be. Well, 21 here is the most that it can be. Everything less than or equal to 13 will be less than that. And 21 will be more than, will be the maximum. So that's kind of how I went back and checked it. Any questions on these before we look at 6? Okay, let's go ahead and check 6. I got 2n plus 10 is greater than 3n minus 4. Some of you might have put 4 minus 3n, but remember, I got it confused with the last one we did on the other side. But when you have 4 less than a number, that means the 4 less than is going to be moved behind that other term. So that's why I moved it. Now, the way that I grade homework is if your inequality is wrong, I take off points. But if your work based on the wrong inequality you created is correct, then I give you points for that work and that answer. So like this might be worth 4 or 5 points. So if you put 4 minus 3 in, I would only take 1 point off as long as everything else was right. Okay. Okay, let's go ahead and move on down to these story problems. Number 7, it is Steven's turn to buy snacks for his baseball team. If he has a total of $50 to spend and there are 16 players on the team, what is the most he can spend per player? It's going to be very much, let me tell you that. So the first sentence is not needed, but it's there to lay the foundation for the story. If we understand what the story is, it makes it easier to come up with the equation or the inequality. So he has a total of $50. Can he spend more than $50? No. So, oops, wrong one. So here is what he has. He has 50. This is what he can spend. Okay, what he can spend. So what we don't know what he can spend yet, but we do need to come up with the expression that represents how we're going to figure out how much he can spend. So what do you think if there's 16 players on the team, how would we come up with an expression for this right here? Anyone know? Say that he could spend $2 per player. What would you do to figure out if you had enough money to spend $2 per player? Think of it that way. What would you have to do? Yeah.
Multiply it.
Yeah, multiply 2 by the amount of players. So since we don't know if it's 2 or not, we have to come up with a variable that represents the cost per player, and we're going to multiply that by 16. So I am going to choose P. Why not? 16P. Okay, so let's look what he can spend. Can he spend more than 50? No, he has to spend less than 50. Can he spend exactly 50?
Yes.
Yes, he has 50, so he can spend it. So that is our equation right there. 50 is less than or equal to 16p. Kind of how we break apart a problem. So then we have to divide both sides by 16. And we're going to use our calculator because I don't think that anything times 16 actually equals 50.
It's 1/8. Rated 1/8.
Okay, but we need it as a decimal. Is your calculator giving you fractions?
No.
Oh, you just know that 0.125 is 20? All right, but we're dealing with money. Okay, so here is the thing. We got 3.125 is greater than or equal to P. But we have to translate that into money. Okay. Does anybody know how we would translate that into money? Yeah.
Oh, by the sorry, I'm blanking.
That's okay. Are you wanting us to round?
100. Yes.
Okay. So if we round, we get 3.13. So let's multiply that by 16 and see if we're less than 50. So 3.13 times 16. We're 8 cents over 50. Can we spend $3.13? No. So in this case, we would not round it. So our answer is 3.12 per player. Please write the dollar units and the other units. So here we have $3.12, but we also want to know what are we spending it on per player. So this would be your final answer right here. Okay. All right. Let's go to number 8. Wireless earbuds are sold for $75 per pair. If a total of 1,521 is general expenses plus $25 per pair are spent manufacturing the earbuds, how many pairs must be sold to make at least a $9,000 profit? All right. What is this saying? Okay. Let's look at this because this is where we stop, right? This is too much. I can't do it. I'm going to go ask Mrs. Weatherman or I'm going to ask somebody else and try to figure it out that way. But what I want you to do is I want you to think about what's going on in this story. Earbuds are sold at the store for $75 each. Okay, so they're getting $75 for selling them. But then how much does it cost to manufacture them? Okay, well, 1,521 is general expenses. So they have to spend that much on something. All right. But then it costs them $25 for every pair to make them. So maybe here are the parts to make them, and then they have to, and then $25 per pair to actually put them together. All right. So these are their expenses right here. This is how much they're selling them for, but they want to make a profit of $9,000. That's how much they want to make. So we need to figure out how many pair of earbuds do they need to sell to actually get out of the hole from making them and then earn a profit of $9,000 by selling them for $75 per pair. Does that kind of make sense? A little bit. Let me put it in simple terms. If I want to make cookies for this class, no. If I want to make cookies for a fundraiser and I spend $100 on all the supplies and then I charge $5 a cookie, these got to be really big cookies. Okay. But I want to make a profit of $200. I have to give myself back the $100 and then I have to make $200 for a profit. That means I need to sell at least $300 worth of cookies, right, to make my profit. And that's kind of what this is talking about. So with that said, I'm going to just give you a minute to think about it. All right. I want you to think about what is taking place. Even if you come up with one expression from this word problem, I want you to just to come up with one expression or a variable or the inequality symbol. Come up with something that we can plug into this inequality. So I'm going to pause the video and let you think about it, and then we'll come back. Okay, so we're going to take apart the word problem. And we know that the company is selling each pair for $75. So they're taking in that money. And so that would be positive 75. Oh, did you guys, is it 75 per pair or just 75 flat?
75 per pair.
Per pair. So that would be a plus. So this up here needs to be 75p. So add that there. And then sorry about that. Okay. And then their expenses here are $15.21 and 25 per pair. So it's a one-time expense of $15.21. And since it's an expense, they have to pay out that money, take that out of their bank account. So it's a negative $15.21. And then it costs them $25 per pair to make them. So that would be a negative 25p. Okay. So this right here, what did we say it was? This is how much they're going to spend and how much income they're taking in. So that would be 75p minus 1521 minus 25p. But then we have the $9,000 profit. This is what they want. They want to make, which is our profit, at least 9,000. So then the question was, does this have to be more than, or can it be less than? And we decided that their spending and their income combined must be greater than, and it says they have to make at least over here, so they can make 9,000, so it can also be equal to. So that is the equation that we have. Now what we're going to figure out is, here's the question. How many pairs must be sold? So we have to answer that question. Oh, you can't? Okay. Oh. There we go. It was the same thing that was up there. All right. Well, oops. I put two. What happened here? I forgot my fives. I don't know what I'm doing. All right. Hold on. So it's 75p is the profit per pair minus 1521 expense for maybe supplies minus the 25 per pair to make each one. All right. So the first thing we need to do is combine like terms. So I'm going to combine my 75p and my negative 25. Okay. And I end up with 50p minus 1521 must be greater than or equal to the 9,000. Now I'm going to add 1521 to both sides. Oops, I didn't set that up right. And I end up with 50p is greater than or equal to 10,000. You know what? I think I messed up on this. Hold on. Oh, yeah, it's 10,521. Then we're going to divide both sides by 50. Parker, is this what you did? Oh, maybe my calculations are wrong. Let's check. 1,521 divided by 50. Okay. I got 210. You guys probably can't see that. So P is greater than or equal to 210.42. Okay, listen up. How can you sell 0.42 of a pair of earbuds? You can't.
So you have to round up.
So in this case, we would round up because 210 is not going to be at least 9,000 because you need that extra 0.42. So we're actually going to, we need at least 211 pair. So this right here is our final answer. Because we can't sell okay. There we go. All right, guys, I want you to try 9 on your own. It's definitely simpler it's less complex than the one we just did. Now, don't forget though, I put problems like this on the notes because you're going to see them in the homework. So make sure you refer to these. But right now, I want everybody to work on example 9. And I'm going to pause the video. Okay, so just to explain this a little bit, on the positive 30p is that they're earning $30 per lawn. But the expense every week is $13. So you have to subtract that $13 expense. Now, if they were saying they wanted to know how much you would earn in a month, then you might have two different, you would have negative 13p as well, but that's not what they're asking. So for this one, I have this on their spending and earnings side. Their profit has to be at least 200. It can be 200. So what they spend and earn together must be greater than or equal to the 200. And there was one thing I forgot to mention when we're dealing with story problems. Notice up here on example 7 where it says $3.12 per player. You should put no more than that amount. And for 211 pair, at least 211 pair. JG. And for 8 lawns, you should have at least 8 lawns. So you need to add that verbiage to your answer in order for it to be fully correct. Okay. All right, we're going to go down to example 10, last problem. And so Jenny has scores of 78, 89, 90, and 96 on her first 4 math tests. Out of 100 points, what score must she make on her next test in order to have at least an average of 90? And this is something you can actually do to see what you need to do to get what you need to make in a class to get the semester average or the quarter average for report cards. So actually, this is pretty useful to you as students. Does anyone remember from 6th, 7th, and 8th grade how to find the average of something? Mason?
You add up all the numbers and then divide by how many.
Yeah, you add up all the numbers and divide by how many there are. Okay, so now next question. How many tests are mentioned in this problem?
4.
5.
1, 2, 3, 4. Next test 5. But we don't know what the next test is. And Mason said you have to add all the tests together and then divide by how many tests. So we're going to add all the tests together and divide by 5. But we don't know what the 5th test is, so we're going to use a variable for that. So we have 78 plus 89 plus 90 plus 96 plus x for the next test. You have to divide all of this by 5. However, how much does she want to make? At least 90. So this has to be greater than or equal to 90 in order to make at least 90. All right. Now, what would be the first step you would do to solve this problem? Okay, we can add all like terms up here. So let's add all those together. So we're going to do this real quick. We're going to add all those together. Did anyone figure it out? Yep, 300. Did I miss up? 78, 89, 91, and 96. Did you get 353? 78 plus 89 plus 91 plus 96.
It's not 91.
Oh, it's 90. It is 90. Okay, so it's 353. 353 plus x divided by 5 is greater than or equal to 90. Now what are we going to do? Multiply both sides by 5. So when I multiply by 5, these cancel out. Left with 353 plus x is greater than or equal to 450. Now we're going to subtract 353. Okay, so she has to make at least 97%. Okay. Do not forget to put the at least. All right. Make sure you use your notes on your homework. They will be helpful. And that concludes lesson 4.4 on inequality word problems.